Yes.
Perfect.
Okay, hello. So, where do I start? Okay, so it's quite a nice thing going this late in the program because it means that I can address some things that have been foreshadowed quite nicely by some of the previous talks. I'm going to talk quite quickly because I'm speed running a couple of experiments that I did over my PhD, and the idea is that I'm aiming to address a very specific issue that affects a very specific thing that we often try to do in this field. So first, I'm going to sort of give you some operational definitions of what I'm talking about, how I'm approaching things, what metrical ambiguity is, and where it's useful and some pitfalls we have when we try and use it to study other things. Then I'm going to talk about a couple of experiments that we did to find some ways to address this. The first experiment will be a kind of search paradigm, so where to find ambiguous rhythms and how to look for them. Second experiment is how to test that what we think we found is reliable and whether these are rhythms that you can really use in your own studies. And then I'll conclude just by saying what you can do with these rhythms and what you probably shouldn't do with these rhythms. So, bit of background. Metrical ambiguity. Well, when we talk about rhythms, we can think of them as existing on a grid of subdivisions. So you'll have a very fast, the fastest structurally relevant rate in your rhythm, like taka 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 taka. You have an isochronous pulse that goes very, very fast. When we talk about beat, what we really mean is groupings of these subdivisions. And when we talk about entrainment to the beat, we talk about entraining to one of the groupings that we have. And this grouping is recursive, so you'll have groupings of 2 that will group into groupings of 4, that will group into groupings of, in this case, 12. So on the left here, we have the 3 grouping structures you can have with 12 subdivisions. For specific grid sizes, you can have multiple grouping structures available to you. So the smallest case where this applies is a meter with 6 subdivisions. So if you have 6 subdivisions, you can group in either 2 groups of 3, like takita takita, or 3 groups of 2, taka taka taka. Both times you have 6 subdivisions, but you have a different structure that results from that, different beat sizes, and a different rate that you're entraining to. This is really interesting for entrainment because it allows us access to more of the top-down cognitive aspects of entrainment. So if you have an invariant stimulus, but you can perceive it in multiple ways, you can ask questions about what internally affects how we find the beat of a rhythm or similar such questions. An important point to make is that we say a rhythm is metrically ambiguous if it can be easily interpreted in multiple meters. Because in theory, you can forcibly interpret any rhythm in any meter if you're stubborn enough. So, when we use metrical ambiguity in science, often we start, the default rhythm is polyrhythms. So a lot of people have probably been thinking this the whole time. We use polyrhythms, and they are useful. In theory, they are metrically ambiguous. A polyrhythm, for those that don't know, if you take the groupings that I just did, like takita takita, taka taka taka, you put them at the same time. You create a composite rhythm from those 2 isochronous pulse trains, and it produces a meter with the number of subdivisions that's the multiple of the 2 pulse trains. So in this case, 6. This is a 2 against 3 polyrhythm. And in principle, this should be ambiguous because the listener will hear this rhythm and they should choose one of those 2 isochronous pulses to hear as the beat, and then the other pulse becomes a sort of rhythmic figuration on top. In practice, what we see is there's a really clear preference for binary subdivision groupings, the taka taka taka, 1 2 1 2 1 2. And the ternary beats are actually experimentally quite difficult to make people do. And for this reason, I actually say that polyrhythms aren't very ambiguous, because if it's difficult to hear it in the opposing meter, there's no ambiguity there. You know what meter you want to hear it in, so you hear it in binary. The issue I'm trying to address is, can we find rhythms that are more ambiguous than polyrhythms? And the way we do this, so first we do a very breadth-first search. We define a search space. So in this case, we use all of the unique 12-unit cyclical rhythms. So that was 6, this is twice as long. the search space here is that big. There you go. That's all of them. So we just have to find which ones of those are good. And once you have a search space, you also have to know what to look for. So we came up with 2 ways of conceptualizing ambiguity. You can have the case where 2 individuals will hear the same rhythm, but one person may tap a 3-unit beat, takita, 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 takita. The other person may tap a 4-unit beat, taka, 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 taka. The within participant ambiguity is the same thing, but one person will hear the same rhythm twice and they change their mind. I won't go too much into the maths for like how we actually come up with a metric for this. It's not anything particularly interesting, and I don't have very much time, but I can answer later. This study, so we have 351 rhythms. We played them to participants online in a simple tapping task, listen to the rhythm, tap the beat. We alternate the tempo between a fast and a slow rate, just to make sure that people can't lock into one tapping rate all the way through the experiment, because then you'll have like really strong history effects. So alternating between these 2 rates that shouldn't have too much overlap in the multiples of 2, 3, 4, etc. And the result of this, we narrowed it down to 15 candidate rhythms. So we took our 3 metrics. We have the between participant fast and slow, they're calculated separately, and then within participant, necessarily we calculate across tempo because they only hear the rhythms twice. And we take the average across these 3 metrics, and we group it by the lowest score. The reason that we do this, as you can see here, so each row, it will have the lowest score. So in the top row will be the fast between ambiguity metric. And we do this just so that we can spread the unambiguous condition around, so that the stimulus that we choose should be robust when we start adding more conditions. So if all of our rhythms are actually quite unambiguous at slow tempo, if we add an even slower tempo, that won't really do anything, probably. So we have 15 candidate rhythms grouped by lowest score. We select the top 5 from these 3 groupings. Then, to make sure that we haven't just sort of found some spurious thing that only happens just once, we take these 15 rhythms and we look at them again, and we look at them more thoroughly than we really could have the first time around. With 351 rhythms, it's difficult to get a lot of data per rhythm, so we kind of have to just get a little bit on all of them. The additional conditions that we have, so this time we now have 4 subdivision rates. We've got 2 more extreme ones on either side. We nudge the values a little bit from the previous experiment just to, again, avoid this overlap of the beat multiples. We also have 3 rotation conditions per rhythm. So the first time round, we played all of the rhythms in the rotation that they were generated. This time, we chose 3 rotations per rhythm, and we sort of loosely tried to target the 3 possible meters that you can have in a 12-unit grid. So the 3 that I showed at the very beginning. And we used this Lettle, Jackendorf generative theory weighting-ish approach for that. This experiment was in the lab. It let us have more accurate timing information, so we can look at absolute time in relation to onsets, which is difficult to do with an online paradigm because of the latencies. And again, we alternate the 4 tempos, and we have 3 rotations, so now each rhythm is heard 12 times. So we actually get a nice amount of data from this. In addition to the new conditions, we also chose 15 rhythms that we paired with these candidate rhythms, and we chose these to be as unambiguous as possible, and we matched them by how difficult they were and how many onsets they had. We again rotated these rhythms to target 3 possible meters, which has the implication that some of these may become ambiguous because we've chosen rotations that match specific meters. We'll come back to that. Did it work? Yeah, just about. Here we go. So what you see here in the box plot is the 4 between participant ambiguity scores grouped across all the rhythms, and the pink is the ones that were classified as ambiguous, our candidate rhythms. The blue is the ones that were unambiguous. And the number is bigger, which means the science is more good. So we did some fixed effects modeling. So we fitted a model with a quadratic tempo term. That's too far. Where am I? Yeah, we found there was this tempo effect. I'm hesitant to interpret it too much, just because there may be some selection bias stuff going on, but what we did find was that the slowest tempo was the lowest ambiguity across everything. But interestingly, there's this kind of contradictory finding that we had, which is that, so we had low ambiguity at slow tempo, which is a low event density, but we also had high ambiguity when there were fewer onsets, which is again low event density, but there's this sort of non-linear interaction between the two types of low event density that was quite interesting. We can break this down by individual rhythms as well. So here is a big mess of each specific rhythm that we have. So it's the same basic plot, but just each color represents a rhythm. And we see, I need the long stick from yesterday, but I don't know where it is. Some of the rhythms kind of hop the fence a little bit. So we have, like, for example, 24, the second lightest orange one. When we play it very, very fast, it actually becomes very ambiguous. So there's some, it's not as cut and dry as, oh, a pointy stick, thank you. This one. So this is one that we chose to be unambiguous, but when we added this new very fast condition, it actually jumped the fence and became ambiguous. And likewise, there were some that we chose to be ambiguous, but when you play them very, very slow, not so much. There was also some effect of rotation that I won't go too much into because it's a little mixed, but rotating did affect some of the rhythms. Where are we? So again, we order our rhythms by mean and ambiguity ranking across the metrics, and we suggest using the top 8 of these rhythms. So 6 of these were ambiguous in both experiments, so they seem to be quite reliable even with the new conditions. And the 2 that were unambiguous and hopped the fence, it seems to be a result of the new rotations or the new tempos. These are the 8. Here you go. I have sounds that I can play at the end in the questions. To wrap up, conclusions, how we suggest you should maybe use these rhythms and how not to. As a general recommendation, we found that rotation didn't tend to alter the perceived meter very much. In specific cases it did, but across the board it actually didn't do as much as we thought it would. So we say use the rotation that the rhythms were generated at. And each rhythm has a tempo that it seems to be most ambiguous at, that we can, again, use that. But you can also use specific subsets, and you can also potentially extend the ranking and select some lower ranked rhythms if you have a question in mind that you know would suit particular rhythms. So, for example, if you're interested in what metrical switching looks like in the brain, you can use high within ambiguity rhythms. These are the ones where people change their minds, and then you can measure people's brains when they perceive it in 3 versus 4. Or if you want to look at a tempo interaction, you can split your rhythms by the ones that were ambiguous at fast and slow, and then use the between ambiguity rhythms. Don't use them for cross-cultural research without replicating this paradigm. As we saw with Dan Cameron's talk yesterday and some of the things Martin was saying earlier, like a lot of our metrical biases are cultural. They come from the music that we listen to and grew up with, and yeah, other cultures are very, very unlikely to have the same frequency of 3-unit beats versus 4-unit beats, so these won't really work there. Thank you very much for listening. Thank you to Molly, my supervisor. Special thanks to the group back in Frankfurt. Here are sounds for the rhythms if anyone wants to listen. So, thank you. Questions? Ooh, lots of hands.
So I was slightly surprised, actually, that the ones that were ambiguous were all well-formed. But my question was, why did you not try random rotation starts? I wasn't clear how many repetitions of the rhythm they heard before they had to make the judgment. But in any case, why not random start points?
So we did different things between the experiments. The first time round, so one thing is that when you have this many rhythms, you can't test all rotations. Randomizing them is one option we didn't do, but what we did do was we had a fade in. So we tried to minimize this primacy effect of the first onset being perceived as the start of the rhythm. We took that fade away the second time round to make the rotations more effective, I think. Did that answer your question?
Yeah.
Okay.
I still think it would be interesting. You could do sparse sampling after all.
Yeah, it can definitely be done. It's just not the approach that we took this time.
Thank you for an interesting talk. I also like that you're having this cliffhanger hanging there. But I also appreciate that I am able to ask my question before you play.
Sure.
Because I'm wondering about the perceived task difficulty and their actual performance. So
Yeah.
I don't know if you mentioned how long the sessions were, but I would be curious to hear about the actual experience of the people and their performance. And added to that, I'm very curious to hear the rhythms themselves.
Yeah, so in terms of task performance, it was quite low. So we actually see this a lot of the time with online tapping tasks, and also with these, to get ambiguous rhythms, they need to be difficult to interpret. So we had a lot of data loss just because people couldn't find the beat. What was I going to say? The sessions, so actually I forgot to answer the other question about how long the trials were. The first time round, people heard 10 repetitions per rhythm, so about 20 seconds-ish. Second time round, we saw that we could actually shorten that a little, so it was around 7 repetitions for the second task, which seemed to be enough for most people. Like, the extra, having 10 repetitions didn't make it any easier, so. Did you want to hear a rhythm? You got a preference?
Yes. Connor says, "Don't tease me, I want to hear these rhythms." So, holding our breaths.
What's my favorite? My favorite one is, where is it? Is it this one? I think it's this one. Oh, and I have to mix it. Anyone know where the beat is? Want to hazard a guess? Or I can just demonstrate. So one way that you can hear this would be, that would be ternary beats, so 3 units. Takita, 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 takita. To hear it in 4 units. There you go. Any others?
Favorite.
Huh?
If you have a favorite, do you have a least favorite?
Oh, there's everyone else's least favorite. This is the one that people were worst at, which was this one. It's quite unstable. It's kind of funky. Sure.
I'm partly also looking at Martin Clayton for this one, but
Okay.
the relation to the actual, timeline, and I'm curious to hear, and I guess that you also looked at it, how they relate to. I was recognizing some pattern that I'm familiar with, but I couldn't label, or because I'm definitely not so experienced.
I actually emailed Rainer when I saw one of these rhythms because, so my master's, I used his Malian djembe corpus, and one of the rhythms, I think, might have been the one that I played. It's basically one of the djembe timeline patterns just missing a single onset, so it's like almost exactly mapping onto a very well-established traditional African rhythm, which was really cool. And when I showed a poster at RPPW, someone came up and said, like, that's just a Bulgarian rhythm. I was like, sweet.
Nice.
So like, these are things that exist in the world, which is cool.
I'm and sorry, really last comment, but instead of tapping, I'm referring back to the talk of Alexander Demos yesterday, I would be curious if you would place them in an actual dancing paradigm or test. How would people actually move full body motion instead of the simple tap or head banging or whatever you want? Because like your favorite rhythm, really triggered some associations to other stuff that
I think so one thing that potentially could happen here is there's the opportunity that people might start perceiving these in additive meter. So one thing with like a lot of these rhythms, why they're popular in for example, Balkan music, is because they have like long and short dance steps, so they'll group in 3 and 2, and then that's a way of making these very unstable rhythms actually less unstable, is you can have strong beats where you want strong beats, where you can jump up and down and land at the right time.
Thank you.
Cool. Thanks.
We have also a question online, which is where exactly can I find these rhythms online?
The paper is on its way. Online, they're not online yet, but they will be. So
And presumably by next March.
by next March. Yeah. You're also welcome to screenshot this if you just want to like quickly play around with them.
And another question here?
It'd be interesting to know what they thought the pulse rate was in these ambiguous ones too, of course.
What do you mean by pulse rate? So,
Well, when you've only got 4 out of 12 in your conception of them sounding, they may have a very different idea of where the other pulses are.
oh, like the subdivision rate. I guess.
Yeah.
Yeah.
12 pulses is what I mean.
Yes. Yeah.
N beats to be described.
Yeah, there was one thing I kind of thought about, which is, so one really interesting thing we found was that 3 of these rhythms are almost isochronous. So like here, if you move that onset 1 to the left, then it becomes isochronous. And in that case, like, there's not any need to perceive all 12 pulses. Like, you can just perceive that as an isochronous pulse, and then one of them is just a little bit wrong. So there's not something that I've really thought of a way to analyze whether people really were perceiving all 12 subdivisions, but it is an interesting, like, theoretical thing to try and untangle from this, is whether people were really perceiving 12 or whether they were quantizing to a different preferred meter internally.
Can we also hear that one?
Yeah, sure. Which one was it? This one?
Mm-hmm.
I think.
Yeah.
Here. Right. I think. Yeah. Well, you can hear it syncopated in 4. It's got a nice syncopation. So if you have. What's that? But you're hearing it 3, aren't you? Is that? No, 4. Oh, okay. That looks like 3.
3 syncopated.
Okay. Oh, so like this, yeah. Normally it gives me a thing that I can pause them with, but you just have to listen to the whole thing. Sorry.
Super fun. And I also missed asking Clara a question, so I'll ask her after, but give it up again for Matt.